Hello, everyone, and welcome to Constellation, our video series where we talk about people throughout the star field of companies and technologies that Qualcomm, Snapdragon, Dragon Wing are all associated with. I'm your host, Sascha Segan from Qualcomm's PR department, and today we are talking about cars. I am very excited about this because you may or may not know that your car is a powerful computer. There are, in fact, many powerful computers in your car, and we will get to that. We will get to the details of that, and we will get to the details of how that software is programmed, arranged, and developed so that people have the best possible driving experience throughout this hour. We are going live on YouTube, LinkedIn, X, and of course the Qualcomm Developers Discord. I am a regular denizen of the Qualcomm Developers Discord. If you're not a member of the Developers or Insiders Discord, please join. And I have two of our experts on automotive here, two of the guys who really direct and develop the way the software and systems go in the advanced automotive cockpits of 2026. That is Mark Granger and Girish Shirazit. Say hi, guys.
Hey, everybody. Great to be here.
Hey, folks. Looking forward to the conversation.
Really great to have you guys here. Okay. Who has the dog?
I do.
What kind of dog?
So it's a golden doodle. It's a mini golden doodle. A
And,
mini golden doodle, which is not mini.
and he wants to be on the stream, but is not being permitted.
Yes. So I'm just keeping him out.
Okay. Commenters, if you want Girish to let his dog in, tell us, and maybe we will at the end of the stream. Because I am always pro dogs and babies on the stream. So
I love it.
okay, just to start out, now, first of all, so I came to Qualcomm 3 years ago, but I have actually known Mark much, much longer than that. I used to be a journalist. I came to Qualcomm because, in part, I was reporting on a lot of Qualcomm's products for years and years and years. And Mark helped develop the smartphone chipsets for TI back in the day. And Mark, I wanted to ask you what your favorite TI-powered smartphone from that era is.
Probably because I used it for maybe the longest time, a Nokia N95. It was one of these slider ones that had a 5-megapixel optical zoom lens on the back with the Leica optics and whatnot. I did kind of like that thing for sure. So
I have to get one of those for my phone museum, actually, because I remember that in the Nokia N95. I remember writing something like, the Nokia N95 sounds like the future calling.
yeah,
Like it felt so advanced.
Yeah, I found some way to get my corporate emails on it at one point in time.
Whoa.
Anyways.
I was going to call out as my favorite the LG Optimus 3D because so I don't know if the viewers will remember, but in like 2010, 2011, there was this massive fad to suddenly put glasses-free 3D screens on everything, and like 2 years later, the fad disappeared and no one wants to talk about it.
Yeah, that was definitely we were all sure it was gonna take
3D
off.
was gonna be the future. Yes. Yeah. And
although that I was thinking a little bit about our discussion today and those old times, and I mean the one interesting thing is the fact that I feel like we're kind of in this phase of when smartphones really became smart, right? Which is really coming from the both the Android and the iOS, and just how amazing the progress is right now, and that's how it used to be in the smartphone space. Every year there was something just groundbreaking, right? So.
Yeah, now we're seeing it in a bunch of other categories of technology, and we're seeing it in vehicles going from essentially mechanical machines that get you places to these whole intelligent cockpits, like an intelligent center of your world, right?
Absolutely.
So Girish, to get into some of your background for the viewers, you've been working in industrial computing for many years, and I would love to hear about some of the extreme environments or extreme situations that you ended up designing products for.
Yeah, sure. So the one thing that I think it was around a decade ago when before getting into the SoC land, I used to be one of the lead architects to build the industrial computers for x86 based using x86 and NVIDIA based SoCs for defense and for science and transportation. And one of the products that we built was sort of a clustered system that went into the Large Hadron Collider. So it was really so the weirdest would be that I would say that is the LHC. So it was really a six clustered Intel rugged system that went into LHC. So I would say that is I wouldn't say weirdest, but that is something that really is close to my heart.
So if a computer is going into the Large Hadron Collider, like what
Yeah.
sort of environment does it need to be able to resist? Like, is there a radiation element? What's the
The,
issue?
one of the biggest things has been the EMC, electromagnetics. So that has been one, and then the reliability had to be because there used to be multiple levels of redundancy. So for any function, I mean, yes, today in automotive we talk about one out of two, two out of three redundancies, or there it was to be even further. It was to be 6 out of 8, and kind of redundancies that you'd had to operate because of the failures that you would have experienced in a EMC situation. So that was, and I was very much focused on the software side. So really, we needed to build the resiliency in the software too, to handle all sorts of failures of different systems, which certainly helped in the automotive land, I would say. Just that, yeah, in automotive, not as bad as LHC. When something happens in LHC, maybe the entire world will collapse.
Yeah, I was going to say a lot of that industrial and sort of a lot of that industrial computing, a lot of the issues are really similar to the
Yes,
issues that you find keeping a car up and running in various environments, right?
yes, yes, indeed. And at the time, at least my focus was very much around using the SoCs to build system architectures. So very much, it did give a view on how the SoCs need to be developed, designed, deployed. And when I say SoCs, not just the chips, but the entire stack needs to be developed, designed, and what kind of environment it needs to be in.
Mm-hmm.
And now that I'm more inside the SoCs, it gives a much better perspective, I would say.
Okay, great. Then yeah, let's launch into talking about what these computers are and what they do. Now, we're focused during this hour on the cockpit. There are, of course, various systems within the vehicle, and a lot of people, there's a lot of conversation right now around automated driving, but I want to talk about cockpit for this hour. So give me a sense of how powerful a state-of-the-art cockpit computer really is, like in terms of versus a phone or a PC, what kind of CPU capability, GPU capability we're talking about in one of these vehicles.
Right, right. So let me take that. So I mean, I think it is really amazing how quickly the compute has expanded through the years. From before just being able to take care of one display and whatnot. But we have in that, let's call it state of the art, right? Our Snapdragon Cockpit Elite that we announced a year and a half ago, and is about to get into production with a few of the lead customers. That thing brought 3x of the CPU of the highest performing solution that is shipping today, right? 3x of the GPU, and then over 12x of the NPU. And you kind of asked about this performance versus smartphone versus everything else. And the really unique thing about the automotive space is the fact that all of these systems need to work concurrently, because it's not like a phone where you're kind of doing one, maybe a couple things, but one or two things at once. Here, you might be taking care of multiple audio zones, multiple displays. You might be doing driver monitoring and whatnot. And so that's really where some of the biggest, I'll call it deltas, come in, are these SoCs that are fundamentally designed to handle this concurrency that is necessary.
So sorry, go ahead, Girish.
No. I mean, just one additional point to make beyond what Mark already mentioned is all of this needs to be deterministic. All of this needs to be safe. Just having one is having all of this compute working concurrently. Second is doing all of that with safety in mind, with determinism in the mind. Now that is what makes this pretty unique and a real tough situation for an SoC to be in.
And of course, let's not forget a 0 DPPM target, right? For very high quality.
So yeah, that opens up a whole bunch of questions for me. So like, is it does this mean that these SoCs are much more are much more interested in multi-core workloads because you're running so many things concurrently than you would see on a phone or a PC, where a lot of your time is spent very much on a single prime core, and then it just spins up the rest of the cores only when needed? I guess that's my first question. Is this a situation where you have a multi-core SoC and they're all firing at once more often than you see in other domains?
Yeah. I think, and Girish, you can add as well, but I think definitely multi-core, and most people, when they hear core, they think CPU, right? So yes, tens, almost 20 odd CPUs firing away. But, really, if you take a look at our SoC architecture, right, you've got all of those various different cores, the NPU for AI, the GPU for all the graphics rendering, audio DSPs, right, to do all of this awesome audio routing. So you really get extreme multi-core, if you will.
Yeah, and just to extend to that, it's all about heterogeneous compute as such, right? Like Mark said, right? Yes, we are talking about multiple CPU cores, but in our GPUs there are obviously multiple shaders. Our NPUs have multiple cores in it. Our DSPs have multiple cores in it, and also you have something what we call as the safety island, which is small. Well, we say small when compared to the chip that we have, but a small microcontroller kind of subsystem within the big CPU, where you can run safety workload, which is also multiple cores. It's around 6 of R52 cores that run in over there. So really, it is not just about the CPUs being multiple core. It is using this heterogeneous multi-core architecture that we have across different applications need different aspects of these. Like, for example, in case of infotainment, right, graphics, you really need, this is where digital clusters and whatnot, right? I mean, this is where, or visualization, you are really using the graphics code or the DSPs, so on and so forth. But then there are a lot of safety relevant, like for cluster, right? In case of cluster applications, you need safety, in which case you'll be using the safety cores
Hmm.
along with the display rendering and so on and so forth. So these are all the concurrent applications scenarios that will be using different part of the silicon as
Hmm.
such. And in many cases, what we need to do is really look at the concurrencies on how do you make sure that the applications that are running on a system, depending upon what kind of application it is, you really need to give it this guaranteed resources as such so that the user experience is not compromised.
Yeah, that actually was kind of going to be my next question of you have all of these systems with all of these concurrencies, and you cannot see um, you cannot see frame rate drops or stutters in the dashboard. You cannot see you cannot see buffering in the audio. All of these things have to be running at once in a stable condition. So how do you maintain that? How do you guarantee stability on all of these concurrent processes when that's been so hard to achieve once more in other domains like phones and PCs?
Well, it
Um,
starts with great architects like Garish and both hardware and software. But maybe just a few things like when you think of frame refreshes and whatnot, I think the first thing you think of is GPU, graphics processing
Right,
unit,
of
right?
course. Yeah.
And so um, I think it's well known that we were the first one to really commercialize a so-called digital cockpit, which is really the cluster and the IVI running concurrently. And you
Mhm.
have to make sure that that cluster is serviced at every frame, right? So that it's both buttery smooth.
Mhm.
You also need to take into account that the so-called telltales, the the drive mode and whatnot, are all shown in a
Mhm.
safety critical way, right? So the great news is we've actually had this capability for multiple generations,
Mhm.
and now with the Snapdragon Cockpit Elite, we're adding even more hooks for virtualization
Mhm.
into the hardware to allow this seamless experience between domains. And now I'll let the technical guy answer.
no, I mean, and that's the beauty. I mean, this is an awesome question, right? Because to provide those guarantees, right? To provide that explicit guarantee, exactly the sort of the example that you took, that is okay, display has to run, right? So what we do is it's not just a pure play software. Yes, it is a software play, but then the core needs to be what sort of configurability is given by the SoC. And within our SoCs that we have given this quote unquote quality of service. Now, typically, QoS is a term that we associate with networking and so on and so
Yeah.
forth.
Yeah.
But that has been extended within a chip now. So within a chip, we have the ability to say that, hey, for this X application, I need to give a dedicated X resource, Y resource, Z resource.
Mhm.
So I give this a particular application, let's say GPUs, CPUs, NPUs, so that, and then this particular quality of service parameters are really set so that they, in no matter what happens in the other part of the system, you make sure that this particular resource is guaranteed so that it allows you to maintain the quality of service or the experience, the user experience as such.
So you very much have the ability to prioritize your processes.
Yes, prioritization is one, bandwidth allocation is another,
Mhm.
as such. So it's really having been designing or building chips for the last decade. This has been, and for industrial systems, one of the fundamental things has been the, I would say, the last inch problem, wherein going all the way to the last point of the SoC, where you can put these knobs in as
Mhm.
such, so that one, let's say, let's take a memory controller, right? So you might put all the knobs in the world across the SoC, but if you don't put it at the memory controller for that matter, then that becomes a bottleneck.
Mhm.
So that is where, I mean, a lot of innovations have gone into our chip architecture to really give that level of configurability across the fabric of the SoC.
So is there a lot of virtualization going on here? Are these various systems basically virtualized and each of them gets their own chunk of DRAM and their own chunk of VRAM? Or how are these systems negotiating sharing
Yeah.
their physical residence?
Yeah, so there are two parts to this, well, maybe three parts to this equation. One is when you design such a system, you first need to do the spatial partitioning, exactly what you said, right? That is, you might say, hey, I want to give these many cores to, they say, this one VM, these many cores to this another VM, or I want to give these many NPUs, GPUs, whatnot, right? So you
Mhm,
split. You might also give the memory partitioning. So this is the typical static partitioning that you would do within the VMs and inside the VMs too, per process, right?
mhm,
You can give different level of resource allocation. So it's not, the granularity goes beyond. In our latest SoCs that we have, the granularity goes beyond just the VMs. You even can do resource allocations per process as such. But that's one part of the story. The second bucket that comes in, which is a lot more interesting, is the temporal. That is, when you are in runtime, how do you make sure that you have the thing that we discussed earlier, the prioritizations and the bandwidth and whatnot, cache allocations. So that is the second part. That is in our latest SoCs, for that matter. Previously, now in the previous generation, the granularity of what we could achieve spatially or and temporally was around the VM, per VM. But
mhm,
now we can do per process
mm,
as such. So it allows a lot more controllability for us,
mhm.
and gives the OEM the options to even tune the system further.
Now, does that also allow for further hardware consolidation? Because I know that, in previous generations of vehicles, there were various small SoCs scattered around the systems, and now we're going more towards a consolidated single SoC for cockpit, single SoC for ADAS, or even in a flex scenario, one SoC to rule them all.
Yeah, I mean, I think part of some of our traction in the marketplace for cockpit has been this continued integration of more capabilities, both in terms of performance, the right interfaces, and whatnot, so that the OEMs can actually consolidate all these many ECUs, right? Like,
Mhm.
I think there used to be, you know, upwards of 50 ECUs in an economy car, right? And I think a Mercedes-Benz E-Class had like 154 or something like this. So, you know, really, you're right. There's been this consolidation. There continues to be more,
Mhm.
and then you can see it in what we've announced in our roadmap with the flex capability of bringing ADAS and cockpit together. And people are looking at doing also so-called powertrain controls and whatnot. So it will eventually all converge.
Mhm.
Now, the magic, will everyone converge all at once? No, it'll take time and figure its way out.
So, Mark, going from just because as we said earlier, I too was a phone person primarily for many years, going from a phone mindset to an automotive mindset in terms of SoC and software design, what was the biggest mindset change you had to have?
The funny thing is, the most striking thing when I first got into it, a bit more than a decade ago, into automotive, right, was just the timelines, right? Because
Mm,
the timelines were just so long, right?
mm, mhm,
Of course, there were other things that you learned about in terms of the level of quality, reliability, this and
mhm,
that the customers wanted. But it was that timeline that it was sort of like you're so used to in a smartphone. You get a new chip, 9 months to a year later, boom, it's out the door,
yeah.
right? Now, the funny thing is
And then
that
3 years later, everyone's forgotten about it.
Yeah, exactly,
Yeah.
exactly. And it's sort of funny because pretty much the whole auto industry over the last 10 to 15 years has had a schedule compression, right?
Mm-hmm.
As more and more, I would say, both development techniques and just market forces have done it. And then, of course, everyone talks about China speed, and I think we see that every day, right? That Snapdragon, cockpit elite announced, I don't know, a bit over a year ago, is going to be launching before the Chinese auto show in just a month.
Wow.
So it's amazing. So
That speed, the speed and the time frames thing, yeah, that is one of the things I find really fascinating. Girish, how do you test for the stability of a device that is supposed to last 10 or 15 years, as opposed to, as opposed to a smartphone, where, I don't know how long those are. I don't know how long those are architected to last. I certainly have some that are at least 5 years old that are still working. But when you're in automotive, there is very much a sense that this is going to have to run absolutely reliably for many years to come.
Yes, and so there are. It's really the way I would put this is it's one, stressing the system, but second, how do you age the system? How do you test the age of the system, right?
Yes.
And that is wherein a lot of tests happen from, at least, okay, from our standpoint. Let it be the thermal cycling, the power management, the number of times you in hours, right? Hundreds of hours, not minutes, hundreds of hours, wherein we have to do these continuous tests of different thermal cycling, as well as the going through different suspend resume cycles. All of these state transitions that need to continuously happen in different environment for hundreds of hours is really the way you typically test this in different temperature ranges. So that is, I would say, one way of how we test this entire infrastructure. Mark, anything more to add over there?
yeah, well, I think it comes from baseline stability. I guess I would say comes from one, an awful lot of test on our side of the base software stack that we provide to the OEMs, and then a tremendous amount of testing by the OEM, right? So that's sort of this baseline stability, and then as Girish says, there's a combination of just raw hardware capability, AEC Q100 and all this sort of reliability stuff. But then there's, how does this software stay reliable over the years? And I don't know if you were quite going there, but that also ties in some of the over-the-air updates, and especially popular being Android OS in the car, right? That's a place where we've worked with Google to both try to speed the adoption of new versions, but also minimize the work for the OEMs and for the tier ones as they migrate from version to version. So it's
that
a
was actually
multi-dimensional question.
That was actually going to be one of my other questions, which is, how do you manage, or are we even involved in managing the updates when every OEM, I assume, has their own fork of Android Automotive? Like, how standardized is this software?
Okay, so I can split that into two questions. One is, how much are we involved in the OTA? Now, one of the first things that we do is, obviously, we need to provide the infrastructure for you to be able to program the various different firmware and software components that are there in our chip. Now, update cadence of an Android would be different from an update cadence of a different firmware, the visor, whatnot. So you need to be able to provide a mechanism to the OEMs that they can update these different partitions. And this is an infrastructure. This programming infrastructure is what we enable. As now, how do they do this? What update cadence do they go with? It is something that OEM defines. Now, but then, and obviously, as part of, again, just sticking to the first part of the story on what else do we provide as part of these mechanisms to flash and to update the firmware, is that there are different automotive methodologies, like the A and B partitions, the atomic rollback, because this is not a phone. So we need to make sure that, okay, if my partition, if my programming goes, when the OEM is trying to program a particular system, an update, and if something goes wrong, I need to have a backup copy so that I can switch. So that is what we typically call as the A and B partitions. So these sort of mechanisms is what we provide. But the campaign of OTA is, and that infrastructure is typically done by the OEM. The second part of the equation would be on the, like what you mentioned, is the AOS and the forks of AOS. Now, what we have done is we have worked with Google and this close collaboration. You would have even seen a lot of public announcements from our side. We work with Google for long-term support plans for different versions of Android, which is something that we provide and we support on our silicons for all the customers. So the cadence, again, is something that depends on an OEM, but the fact that from Qualcomm standpoint, we can provide a pretty long support cycle for different versions of Android working with OEMs, working with Google, is pretty unique, because as much as an industry and as a North Star, you might want to have an one upstream Android to rule the entire world. That's not going to happen, because obviously all the OEMs do want to put their own differentiation in that. So we will need to even scale with that. We will need to provide a mechanisms for that. We need to provide long-term support for that. And these are all the infrastructure that we have put together to support our OEMs.
And now, is Android Automotive the primary target OS for cockpits now, or are there other OSs that some OEMs are running?
Yeah, so I would say Android AOS is certainly the primary, but then I would also say that there are some OEMs who have cockpit running on Linux. As such, but no doubt, I mean, today the biggest market for cockpit is Android.
Okay.
Yeah,
okay.
for sure.
And so that's the OS layer, and then when you're talking about the UX and what people might consider the application layer, what kinds of tool chains and frameworks are being used to program these things that we're seeing around us?
Yeah. So now, so there is, this is where there is really a lot of choices. I wouldn't say fragmentation. Obviously, this is where the ISVs can bring their innovations and differentiations. For example, a lot of our customers use Qt. A lot of our customers use Unreal Engine. We got into again, publicly announced its engagement, and wherein we support Unreal as part of our platform. We even optimize some of these frameworks to work better on Qualcomm hardware, using a lot of our hardware capabilities. As such, we very closely work with these vendors. So at least when it comes to, from Qualcomm standpoint, we want to support majority of these tools. We don't build applications, the end user application. It's the OEM. But from what we need to provide is this wide range of support for these tool chains, which are optimized for a silicon. And that is exactly what we are doing. And this is where Qt, Unreal, these are really the top in the.
Right, and you said, and now you did say the magic word ISV, and I know you were talking about the toolchain vendors,
Yes.
but that raises, for me the key question of, as I look at these applications running in my vehicle, are they all programmed by the OEM, or is there a hidden layer of third-party ISVs that the OEMs have contracted with that I might not know about?
Okay, that's an interesting question. Okay, so today, the whole, I mean, when I say today, let's say 3 years ago, right? 3, 4 years ago, when this whole SDV story started, the grand vision was exactly what the storyline said is you need to have a app store like what you
Hmm.
have. Well, great. Where we are today is not that bad. That is, yes, I mean, we haven't reached that nirvana state. But today, most of these applications that are coming into the car are by the OEMs, are controlled by the OEMs.
Hmm.
And there are even, I would say, OEM-based app stores that are coming in where OEMs working with third-party vendors, the
Hmm.
ISVs, they work with them and then they enable these applications as part of their app stores as
Hmm.
such. But the way we see this is, at least other than the standard apps that you would find in the Google's App Store as part of the mirror, when it comes to running on actual Android Automotive and whatnot,
Hmm.
it is very much controlled by the OEM.
Okay.
But one thing I'll just throw in, though, I mean, talking about ISVs and these third parties, right? I think that's one of the key, let's call it selling points for the Snapdragon cockpit is
Hmm.
this ecosystem yeah, of third party software suppliers that can be pre-integrated and already known working out of the box on top of our BSP and middleware. And I think it's a great asset to our customers. So,
And now, if someone's developing an app that exists within the uh, Android Automotive, within the phone connected to your car screen sandbox, if someone's developing an app to run on the phone in the car, um, is there a possibility that they could get access to anything like sensors, to anything like, even, uh, location, speed, anything else that is going on around the vehicle from the vehicle itself, or do they have to get it all from the phone? Is it like really, really strictly sandbox like that?
No, so if you really look at the architecture of AOS, there are vehicle HALs, there are vendor HALs. And
Hmm.
through these vehicle HALs and vendor HALs, you get access to the location, speed, telemetry, a
Hmm.
lot of this. So we from Qualcomm side, what we do is we provide access to some of our even silicon data, so on and so forth, through our quote unquote vendor HALs. But
Hmm.
then what the OEM does is they put their vehicle HALs in there so that using the car service APIs within Android, you can use
Hmm.
those to get the runtime information that you can use in your application.
Hmm.
So and that is, I think, the unique part over here is when you run a native Android application, sorry, an Android application natively on AOS, you get
Hmm.
access to all of this runtime, as we would call this, as the chassis data,
Hmm.
and that allows you to bring in car specific innovations as opposed to just bringing an application from the mobile and dropping it over here.
Hmm. Yeah, no, that sounds really exciting, and I think a lot of that's something that the listeners of this show will be particularly excited about. And because I like to give something, some actionable thoughts, especially because for now they're going to be, I guess, developing primarily on the phone connected to the car, because as you said, it's still mostly OEMs in the cockpit itself. Um, if you're developing an application and the the one of the top things I think that ISVs have to consider, right, is intermittent connectivity if they're developing an application to run in a vehicle. And obviously, this is something that you guys think about from the first-party software position. How do you balance? Wanting to be able to access cloud information with this unpredictability of the connectivity during the drive?
Yeah, so it's very much on to how you would design this. For example, right, is whenever you're going to develop an application in the car, you would go with the assumption that you are not going to have connectivity, or you are not going to have consistent connectivity. So when you make that design constraint, then within your application, you start adding support for, say, cached intelligence. You start caching the data, or you start bringing in delayed sync as such. And or the third part would be, okay, how would you gracefully degrade certain functionality as such? So these are some of the design patterns that you start considering as you start developing for this lack of connectivity. And this becomes even more important in the Gen AI land, right? Wherein you might not be able to run a lot of our models and whatnot, sorry, all of your models into the cloud for every query that you make. So this is where in our silicons, what we are doing is we are adding a lot of AI compute so that you can do on-edge inferencing, so that you can still run a lot of AI applications without going all the way to the cloud as such. And that's where it's really becomes critical. Mark?
Well, so can you believe that we went through a stream about auto, and it wasn't until 40 minutes in that the word AI was stated?
But we did that on purpose. Okay.
But I do have to say that that's exactly where I was going to take the conversation as well. Right? I mean, I think people have figured out roughly the intermittent level and the degradation of connectivity over time. But the biggest thing to me that I truly believe from a personal usage perspective is for me to ever really get engaged with an AI in the vehicle, it's really got to be natural, and it has to just work all the time, right?
So it has to have that fallback. It has to have that fallback where, because I think a lot of people have been turned off to using AI in their car, but because they're using Google Assistant, no shame on Google Assistant, or they're using Siri, and those just do not work if the connectivity is shaky.
Yes.
That's right.
Yeah, and also the another key point on that one is the connectivity, certainly, and the other thing though is the immediate response time. That's it. Because so this is when one of our OEMs, and we were I mean, just as an example, is we were at this particular OEM, and they were demonstrating their AI assistant in the car on our Snapdragon cockpit SoC, and they it's not like they did not have option to offload quite a lot of the AI back into the cloud, but they put a lot of resources and a lot of effort into on-edge SLM optimizations. And the difference that we could see is whenever they made a query, the time it took to come back, I mean, say between the inference happening at the edge or going all the way from the cloud to back, even when you have full connectivity, it was quite impressive. So that feedback, that instantaneous response, is also the user experience that you glean for.
So yeah, without naming any specific partners, what are some really interesting use cases for on-device AI in a vehicle that you've seen recently? Like I know what we've demoed, but there's a big world out there of creativity. What's some of the creativity you've seen coming that wasn't necessarily coming directly from Qualcomm?
Mark, do you
Well,
want
I
to?
think I think some of the cool but also very practical, usable use cases, such
Mhm.
as pull up to a parking place, the car, the AI reads the information, debits your credit card so that you can pay
Mm.
them, right? That's a pretty dang cool thing.
Mhm.
But actually, I mean, there's some very wild stuff out there, right? So, for instance, it's actually a software sort of middleware provider that we're talking to, and they are actually planning to utilize generative AI running on the edge
Mhm.
to write code that will drive the UI of the passenger display. So you can wake up one day and say, "Hey, car, please have my passenger display do whatever." And this thing will spit out code, compile it, and take over the passenger display. So that is pretty far out there.
Yeah, so it's almost like it's agentic. That is agentic.
Actually, yes, exactly, Sasha. And I was going to give another example, but after listening to that Mark's example, I thought, okay, no, I'll just embarrass myself.
It's not as cool as the dynamically rewriting passenger display.
No, it's not. So I just thought, okay, let me stand back.
But I mean, by the way, I mean the agentic thing. Again, I do go back to just my own personal, like, am I ever going to use this? And it
Mhm.
has to be proactive. You have to be friends.
Mhm.
I've told it in too many forums, but it's got to be like Kit Car with David
Mhm.
Hasselhoff, right? They were friends. They weren't. It wasn't just a relationship with a car. Um,
So I was at New York Auto Show this week talking to some journalists and getting sort of getting their perspective on high-tech cockpits.
yeah.
And the thing that people most liked, actually, and this isn't going to surprise you, was uh vintage gauge mode.
Mm,
Ah,
They basically wanted the person I was talking to basically wanted watch faces for their gauges, where they could make the dashboard look like whatever their favorite vintage vehicle is.
yeah, yeah, yeah.
And is that something that's is first of all, is that something that could potentially be coming? And then second of all, like, what else have you seen in terms of like UI gimmicks or innovations or fun things out there that could potentially get people excited?
Well, I honestly, that type of thing is there's already some instances of it, right? I believe that Ford has actually done some things with their Mustang display to make it look like, for instance, I have a '67 Mustang. You can make
Mm-hmm.
the cluster sort of look like a '67 Mustang in a new car. So some of that sort of stuff is
Mm-hmm.
definitely coming. Um, I think personalization is going to be a huge thing.
Mm-hmm.
And some people like the mechanical clusters. I'm one of those people. But there's other people who are going to be like, "Ah, that looks just ancient."
Mm-hmm.
And why do I need a needle? Just tell me what the speed is, right? So
I mean, I know at least one guy I can think of who would desperately want a Star Trek LCARS mode for
there you
their
go.
uh, for their dashboard.
and yeah, yeah, I would go with Star Wars, but yeah,
Yeah,
same.
you could go with Star Trek, you could go with Star Wars,
Oh, yeah,
absolutely.
for sure, for sure.
Now, so the other thing that came up at New York Auto Show was the question of when a lot of these innovations start to shower down into non-pure EV vehicles. because right now a lot of the innovation that we've seen has been in the EV world. And at least in the US, and I know the US is going in one direction and the rest of the world is kind of going in another direction here. But at the moment in the US, there is still a lot of desire for hybrid or ICE vehicles. Um, are we going to start to see those catch up in terms of cockpit advancements, or did they stay behind?
I, I, I would say that yes, you will see it catch up. I mean, it was a very convenient thing for us in this high tech industry that this move from gasoline to EV was nearly a mandated thing for some amount of time, right?
Mm-hmm.
And so it gave OEMs the necessity and the need to redo their architecture, right?
Mm-hmm.
And at the same time, we had the very powerful SOCs and whatnot to allow you to do this. So it was great, and that's how it was all geared up. But as we know, geopolitical things, everything transpires, and all of a sudden, yeah, the ICE vehicles are living for many more years. And I think you can watch even public announcements of people reinvesting in, for instance, even ICE engines. Well, you can probably guarantee that people are investing in their ICE platforms, the electronics around them.
So, getting to some of the questions from the audience, to finish up our stream. We have a question that came in that I think is interesting in terms of, it says, what are some of the main advantages that your solution has provided to OEMs where the OEMs have said, and I'm going to edit this question a little bit, where the OEMs have said, it is awesome that you're doing this. This is different than how we did it before. What are pain points that you've solved for the OEMs where an OEM has said you just solved a pain?
Go ahead, Girish. Yeah.
So I'll give one. Is certainly one big one from our standpoint is the way we are addressing the problem of mixed criticality. Being able to run, I mean, again, for the time from industrial, so I was in Intel, then ARM, and then Qualcomm. So the holy grail has been to be able to run mixed critical workloads on a SoC. It doesn't matter whether it's industrial or automotive, whatever. And what was needed is initially a lot of that innovation was happening in software, but the long pole was SoC, the hardware knobs that need to be going, like what I mentioned earlier, all the way down to the last leg. So as part of our latest silicons, what we have done is we have provided that level of configurability for you to really run through mixed critical workloads, giving the level of not only configuration, but the quality of service, the dedicated bandwidth that is needed to run, say, an ADAS workload alongside cockpit. And that, in my opinion, is one thing that has come up time and again from our OEM standpoint. At least that's one tech. Mark?
Right.
Well, yeah, I mean, I think, a couple of things. One that has sort of happened recently, right? So AI, clearly generative AI in the vehicle wasn't something that a whole lot of people were thinking of. Frankly, even a year and a half ago, 2 years ago, let alone 3 or 4 years ago when we were designing the silicon that is shipping into cars right now. But one of the places where something that we've had that people say, wow, this is awesome, right, is the fact that, oh, wow, the devices that we've been producing now for the last 3 to 4 years actually have a lot of AI capability and can be enabled to continually delight the users, right? Mm-hmm. So that's one thing that's sort of really already happened, and that's the type of thing that we try to keep our eyes out for. so that when the market develops, we'll have a solution that people can roll out to.
Yeah, it's wild thinking of having to develop hardware for the potential software needs of 4 years from now.
Yeah.
You need to have a bit of a crystal ball. Getting to another question from Discord. One of our users said, heard you, Girish, say something about the systems tuning themselves automatically. Does that ring any bells?
Okay, so I wouldn't have.
We're talking about virtualization.
Yeah, I think it was we were talking about virtualization and the containers.
But okay. So I wouldn't say, I don't think I mentioned use the term automatically as much as we would want it to automatically tune itself.
So that's an ideal.
That's an ideal situation, but no. But having said that, yes, we do need to tune the system. We give all the configurations, all the tunability knobs that are needed in a platform. But having said that, one of the key aspect that we do working closely with the OEMs is to run the whole concurrency analysis and work with them to tune their systems. How to configure this is really very much dependent on workloads. It is not like one design pattern or one configuration that suits everyone. It is very much dependent on what an OEM's use case is, what are the concurrencies are, and based on that, you then provide the knobs, and then you tune the knobs. And this is the tuning that one needs to do. And certainly this is, as of today, this is not automatic. This is something you need to do.
Okay, now we've got two more questions, and it's interesting because these questions are basically both about implementation. So it's a great way to it's from people who essentially want to buy our products. So it's a great way to send this out. First one is saying, I'm speaking with a company that is building a guided vehicle using onboard SoCs to run AI models for guidance and decision making. And I think this opens up an interesting question of, should this person be looking at our automotive components? Should they be looking at our robotics line? For something described in this way, what part of Qualcomm should they be talking to? Mark, I think this one's for you.
Well, if it's a guided vehicle, probably the automotive space, unless that vehicle turns out to be a delivery robot or a manned space vessel.
A transformer.
Mars helicopter. Yeah.
And then it could certainly be in our robotics space. It could be in our IoT space. I guess a little plug there, though. I mean, given what we kind of have as a one technology roadmap, right? You really have a similar look and feel and tool chain across our SoCs. So develop on one or the other, you'll be able to port those assets easily.
Yep. And if you're in the Qualcomm developers Discord, then our subject matter experts can get back to you and recommend specific SDKs and specific knowledge bases to go to. And I think this question was from that Discord, so hopefully they will help them. And then the last question is for people doing, for startups doing prototypes or experimental vehicles, is there an onboarding flow if you're not a giant, if you're not a giant automotive OEM, and you're working on, say, an experimental vehicle, how do you get into the Qualcomm ecosystem?
Well, I mean, I think you do have some of those avenues through that Discord channel, Sascha, like you mentioned. You can even reach out on the web, but we do have a program to engage with various different third parties, and so if you reach out into one of those sort of forums, hopefully you'll get connected and we can take it from there.
Sounds good. Okay, and I think this is a great place to leave it. Thank you guys so much for coming and talking for this hour. I have found it really interesting, and I hope the audience has too. Constellation will continue. Folks on the Qualcomm Developer Discord, please comment and vote and suggest what our next topic should be. We will call up either some Qualcomm partners or some Qualcomm experts to talk to you about the area that you are interested in developing for. So thanks a lot, guys, and thanks a lot, everybody watching.
All right. Thank you so much.
Thanks a lot.
Bye-bye.